It's not coming in. Where is it? reach करेगा ये नहीं आता यार कहाँ है यार ऐसे नहीं करना चाहिए मुझे not coming in I don't know Good evening. Sorry my last video was disturbed, interrupted, so it could continue only for 17 minutes. I am coming back again to continue that one. This is today, January 6, 2021. Mathematical formula demonstration, equations, geometry shapes, combination of shapes, and this today and also previous dates A to Z 1, 0 to 9. And of course, there are certain other URLs given on text. You can see there's some last videos. And in today's videos, I was talking about letter S. And before that, I was talking about R. I had completed R actually. R was completed. Again, I will try to show you just to refresh that I talked about this R, real R, which is that one. This I talked today just now before this video, and this was important portion in that I discussed with you. 1, 2, 3, 4, 5, 6 areas. Fifth is very important, where this area has been divided into 6 into 5 equal depth trapeziums, where 3 sides are available and 1 is curved, and that curve is also is considered as trapezium. So one area rectangular, second area rectangular, third area semicircular, fourth area rectangular, and this is trapezium. In this circumference, we have to direct this length, which is 24 degree here, subtension angle, and we have used that one here. Now, I continued this, I worked on this. I explained to you area 1, area 2, area 3, area 4, area 5, area 6, and one of them is semicircular area, and that is area 3. So 1 area, 2 area, first, second, fourth, fifth, and sixth are added here. You have seen them, all rectangular, so there's no major problem. And this area 5 is trapezium, which are 5 numbers here, so these are 5, 1, these 5, 1 a trapezium, second trapezium, third trapezium, fourth trapezium, fifth trapezium here. These are here. All these were explained, and rectangular areas were added up. Semicircular areas here, and rectangular plus semicircular is here. Rectangular perimeters here. Rectangular external perimeter, internal perimeter are here. The total perimeter is here. Then circumference is here, and semicircular. And we can say that we use that one. And circumference can say particularly this circumference one is pi r, there's 1.5 r, was pi r 2.5 r. We used from the circumferences, and we deducted from this semicircular length 24 over 180 degrees semicircular arc. We deducted from this p here. This is external parameters, external semicircular length. Can say semicircular external circumference. From this circumference we deducted this value of 24 over 180 into P842, and that's what we did. So there is no problem here. Total circumference internal per external is this, and after that we concentrated on volumetric measurement, which is area into depth, that is for square area, rectangular area, as well as circumference volume cubic meter for rectangular into depth. This is volume for semicircular into depth, and this is surface area. That's two end areas plus parameter. The surface area, two end areas plus, of course, circumference, vertical surfaces. You can say that was R. So go back to SI as I showed to you. S is having easy one. This is rectangular, this rectangle, these two semicircles, and this is what S is about, real S. So we have to concentrate on real S by this. We can say that here you can see this on this. So my S is continuing. You must have seen area. How many areas are involved? Two rectangular areas and two semicircular areas. This is step 8. This is area. That is area 1, 2.75 A. Because of dimensions, because semicircle and other dimensions are there. And area 2, that is semicircular one, that is arc. I am taking arc here, that is pi r, and that is, you can say, 1.75a. R is 1.75a. So here you can say pi r. R is 1.75a into a. That is area. We are using arc here, and then you can say area 3 is also semicircle, which is same actually. So I put just formalize there, but I put plus here, link this. Area 4 is also area 1. Then sum of total rectangular areas, area 1, area plane area is area 1. So area 1 plus area 4, this area, and this area rectangular area, this area is curved area, these two, and we added them. So rectangular curved area total are this. Now parameters for rectangular area is 2.75a plus a plus 2.75 a plus 2.75 plus a plus 2.75 depending on dimensions. If you want, you can see that it's like this. These three here, these three here. So 2.75 a 2.75a, 2.75a. So it's the way. So you can say here we push it like this. Then some circumference pi r. There will pi r is this one, pi r plus pi r per second, pi r then third pi r, because they are 1.25 and 2.25, so we are taking all circumference here. So total periphery is rectangular one, some total periphery is this. Now 3D, you can say we have here extrusion depth. This is plane area, which is here. It is this one, that is G is on here, G, so G by T, and curved semicircular same way, that is here, and this one is here, second end, two end areas plus peripheral surface area, so you can say that is surface area here. Now U, letter U, It's not a difficult one, but it involves again something that is two rectangles, and it involves, you can see, two rectangles 1 and 3, and then semicircle 15, 20, 25. Very easy one, you can say. So we can move to u, and this is u, real one, not square one. Step is same, and we can say real shape area 1 is rectangular 5.5. 5.5 as this is 5.5 into a, 5.8 into a, and area 2 is circular, that's this one. And pi r square 202, you can say here circular is pi r square over to half of pi r square, r is equal to 2a, and that is this half pi r square. Then hold on, yes, this area 2 semicircular, this is half pi r square 2a, and that is 2 into b 584. Then area 3 is rectangular one, 5.5 again. So we have to be careful here. Area 2 circular, that is, well, a minute, area 2 maybe if you see it 15, 20, 25. 15, 20, 25 is axa. So semicircle pi r square over 2, r is this one, and let us see if there's something else. I think no, 628, all this is that 628 half pi r square 2 into, this is half pi r square 2 is that, so 2 is in middle, so this okay. 2 is average of these two, middle one, so half pi r square or 2 into that, 20 in place of 20 it is 2 because of division by a value, and you can say it's 10 here, and you can say here because 2, or we can also say rather than 2 we should convert it to maybe is 2, 15 and 20. When you change ratio it can change also. So what we can say okay, we put here, you can say a over 2 and you may say that, hold on, there's something wrong here, or a over 2 we can say this is a into 0.5, 1 over 2, and let us say, hold on, pi r square, r is 2. Oh, already r is 2, I'm sorry, r is already 2, it's 20 over a, yeah, so it's 20 over a, 20 over, you can say this, so it's coming now, right? Okay, this 20 over b it for, because in case it's not 2, then volume automatically, suppose we make it bigger, in that case you are not taking it to take 30 or something, so I use this one, so means already it's 2 I wrote, but now it should be 20 over, so suppose it's not 10, it's 20, so it will come accordingly, right? So rectangle is not an issue. Rectangular plane is also right. C plus C. Area 1 is semicircle here also. So this is same as this one. So rectangle curve area is this, then rectangle 5.5, all these dimensions 1, 2, 3 and 3, 6 dimensions. 1, 2, 3, 4, 5, 6, 5A, 5.5A, then A, then 5.5A, then 5.5A, 5, and so it's okay. Then you can say here, you can say semicircular is equal to pi r. Semicircle, this one we are talking about circumference, so pi r, that's r is equal to 1.5a, and pi r is equal to 2.5a. And we can say 125 here. Here also I'm saying 1.5 actually. We should say that if we use 1.5, we can say 15 over 10 or 15 over this, we can also say similarly in this same ground and 5 plus this. So this is, let us say rather than 1.5, we convert it to same as we did before, and let us say 15 over 10, actually it should be, so 15 over I should say 10, hold on. What we did there, we smartly we had 20 over that. 20 over that. Depending on dimension, yes, depending on dimension. So 20. But when you change that, we have to be we are equal to 2 we are saying, but 20 is given here, so we can't change 20. That's also important because depending on that, let okay, we'll see. Now we can say rectangular curved here this much, semicircular we got it here, and we can say extrusion is our volume, this one here volume, and we have got area, we have got circumference, we have got parameter. Extrusion is here, plane area is this, and curved semicircular is this. We got this information from this f is area into k is this depth. So we can get volume of circumference also, that is g is here. So we can get this is okay, fine. Then we get the surface area rectangular here, that is 2f, f is the covered area, and I is their parameter into this, that's okay. Then we can say the covered area, so 2 into end area is this 2g, g is this, and j and k, and j is circumference. So we got this value, this is also true. So we have taken u into our account, into our consideration. Now point here is if suppose this is now 50, so 50 means this is 25, and with this 10, so there's no change. 20, suppose it is 60, it will be 30. So it depends, but proportion should be same. You cannot change proportion, that's the important point. Suppose it's 50, it's 5, it's 8, so it should be 5 and 8 same proportions. If 10 into 16 could be proportion of dimension also important. 5 into 8, it should be, you can say 1. If 5 into 10 into 16, it should be 100 into 160. It's like that. You cannot simply say, means you have to depend, you have to see how it works. Scale means you cannot say simply that width you can change, that's true. Width you can change, nothing else. Width here you can change. Okay, now this is stick width I'm talking of. For example, I'm saying this is 10, if I say 20, I keep it 20, so it becomes all this. All this is changes in width. So only point is we have to see whether this radii works or no. Radii I'm keeping, stiff width is same, so radii is important. Radii means here depending on width 50 it would be. Now come on to now we go to what you say u. I think I've taken u, right? We have taken u. We are going to now you have taken, we are going to w. Yes, w means w. Now w is little, you have seen this diagram here. You can see this area and this area, 1 and 5. 1 and 5 are equal. Then 2 and 4 are equal. Then 3 is there. 1, 5, 2 and 4. 1 is trapezium, so 5 is a trapezium. 2 is a trapezium, so 4 is a trapezium. And 3 is a triangle, isosceles triangle. We have designed like that and distributed area accordingly. So there are 5 areas here. 1, 2, 3, 4, 5. 1, 2 and 3 we have to work out. Other 5 and 4 shall be 5 same as 1 and 4 is same as 2. And these dimensions we have from drawing, and we convert them to A. Right, that's what it says, means is difficult at all because there's no curve in that. In curve, we will really look into how to handle this dimension of 2. Even we can say that this radius we can convert to a value. We can convert to a value, and that would work. Already we have converted that. That's not problem. We have divided 20 by a, so we got 2. Or we can take in formula itself also, that whatever already 2 means 20 means 2, 30 means 3. It is in proportion to a. Now W area which is same, area 1 trapezium, area 2 trapezium, area 3 triangle, area 4 triangle, area 5 is trapezium. Then total area is 1, 2, 3, 4, 5. So let us see area 1. It's this one, trapezium. Dimensions are there. 6 point, which written here somewhere. 6.276, 6.406. It's like that, I think. At 6.406A, I showed you a drawing before. 6 point from here to here is this is different. Okay, it's 6.406. Yeah, it's 6.406A and 8.31A. 8.31. So the sum of these two into divided by 2 into A. That's this one. This dimension into A, this dimension into A, and we got some average of this, also half of this, and A. Area 2 is also same with different dimensions. 43 point something, so 4.397 plus 6.276. Half of this into A. Area of triangle is half base into height, and we have the dimension here, and that is half into 1.039A into 1.813A, and that's this one. Area 4, we say it is same as area 2, D860, and this area is same as C, and we can get this area same. So total area is all this, sum C to G, C to G, this row. And parameter now, we have all dimensions. We have taken parameter. I can say, I just count them. Now we have taken this 1.039 here. We started from here, so you can say, I say 1, 2, 3, horizontal 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let us see how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's okay. Only thing we have to check this 1.039. For example, this is here A8, 8.31. 8.31 is this. According to this one, and we can say 1.039 is here, and then 4.39 is here, right? And 4.397 is here. 4.397. That's right. 4.397 again, and you can say 1.039 is here. Same because of this. 1.039 is here. 6.4 is here. I can say 8.3, and it is 8.3 and 1.09, 6.46 is here, plus 4.8408 is here, and 1.039 is here, and 4.408 we got it, and we say 6.4 and 8. So we got this, and here it is all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now coming to volume, 3-day volume. Extrusion is there and volume is there, so we can say H is here. This is total area into depth, and the surface area that is 2 into end area. H is end area, and we can say I is parameter into, let's we got W answered here, right? Now you can say letter X. Letter X. You can see this letter. Let me little export this. So you can say that it's little this way. So you can see clearly 9 into 9a into 8a. We made like this. This is actually at tilted at an angle for rhombus here. This is now rhombus here, and that rhombus has certain angle. That's 7 degrees angle to inclined value. This is vertical. Because this is vertical. No, it's not vertical. We have these dimensions because of non-equality, 9 and 8 non-equality. So it's 7.5. So it's convert all dimensions into you can say into strips. In each arm there are 4 arms now, 4 arms and 1 rhombus. Each arm has 2 strips, 2 trapezium strips. These are trapezium dimensions, 1, 2, then each 2. So there are 8 trapeziums in this. We have this dimension, we have width A over 2, and we have one trapezium, one rhombus here at an angle of 7 degrees. So we can calculate like this. Now go back to our, so it's, in this there's a circle at all, so lateral axis width, here step width, and this is, here we have taken rhombus formula, put here, rhombus formula copied from there. So all details are here. We are only, I want to do is check, means value of A. We have to see how it works on this rhombus. We just use this answers for this. Area 1 is a trapezium. Once we have these dimensions here, 5.014a plus 5.517a over 2 into half over 2 into half a, because there are 2 strips in one. There are 2 trapeziums in one strip, so half is that, half a. We get this plus this dimension, we plus this over 2 into half into this, so we got this one. Area 2 is trapezium, and that is again, area 2 is another trapezium, and we can say it's having a same answer. So area 3 is rhombus, and that we can say L873. 873 is here, L is here, and that is total area. So you use this area here, and total strips. We are used to 7 angle here. We use the 7 angle from this value, and we have taken this dimension from there. So dimension, because it's 10.07, it's not the square one, so it's a little different. And we have taken this. Then total strips area 4. 4 is 4 into, because one strip we have, so we multiply by 4. C866 here. Then we are taking this 2 repeated 4 times. So we repeat this, area strip is equal to area strip, area 2 strip, repeat 4 times. Total strip area is this, and 4 times repeat this. So we can say there, this is repeated 4 times, and this is repeated 4 times, and this is repeated 4 times. Total area is this. Total rhombus area plus total area is this here. So parameter, we can say, we are rhombus, we are not going to do this internal one, so external actually parameter is this. That is, parameters trapezium 1 plus 2. This is this plus this plus this plus this, 4 dimensions you see. Trapezium, this is 5.014a, 7.75a. Let us see which you are taking. This is there, you can say 5.014 is this, and then 7.7 something is here, and 0.69 is here, and this is here. This is all strips, 1 strip into 4, this value multiplied by 4, and we get this value. So we can say plane area is I866. This is plane area, rhombus area plus total strips. We multiply this one, then we can say surface area is 2 and per parameter, 2 into I, this one into parameter, and we get our this work done. We have solved this, and we can say now y. Y is also a little complicated, not as easy. So we have to be a little intelligent to understand how to do it. We are little intelligent about y, how to handle y, how can we what way can we handle that point? We must see, we must ensure it is there. All right, now we're going back to file and looking at y. Y is a little, means it's a little different, as is, my God, this, my, I can't, clearly see this, unfortunately. So this is y. You can say here, go a little up. Let us see here, this is y. 5 into 8. Now you can see construction of y here. It means its actual construction. We have taken, saying we have divided this, a, it is a measurement here, and we have taken here, and then this one has come out itself because there is strip offset here. We just draw this line so that automatically it means here this dimension is known from diagram, and this dimension is original one. This is also known from diagram. All dimensions are marked in, and we convert them in terms of A. That's in terms of A. That's what is important. And this proportion you cannot change. You can change dimensions. Proportions cannot change. Only stick with this variable. Just mind it, nothing else. And you have to control this whole figure, whole drawing by A. That's what it is. So here we can say area division is like, you can say area 1, this is small triangle. Area 2, this trapezium. Area 2 is this trapezium. Area 3 is this triangle. Area 4 is this trapezium. Area 5 is this trapezium. And this is another small area here. You can see 6. After 3 there is small area, small 6, and here it is 7. And these dimensions are given, and we can move through like this. So let us see how can it be done. Y. After this we'll go to letters. Now Y sometimes must be clear what we do, how we do. That's an important point. In Y we have seen 7 areas. So area 1, area 2, 3, 4, 5, 6, 7 we have. Area 1 is triangle area, and this here triangle area, you can say, let me put it this way. It's triangular area 1, very small area. So this is half into base into height, and this is half into B882. It's A into height is 0.236 because it's 2.36 something. So here it's 0.236, or because 0.236A, so automatically it tells how much it is. It, even if it is taking in terms of A, we are dividing A by point, you can say 2.36 over A. You can say that you direct divided, or you can use formula also. For example, in every one you can use formula. Say it is 10, you can say 10 over this. It's one and same thing, 10 over this, but BA2 is there. So whatever changes you make BA2, it will automatically cover. So proportional percentage, you can say. If you say B882, we know B882 is there. There's A. This means we can do that. Now, area 1 is over. Area 2 is the trapezium. That is 4.34 A. Again, I say we divided by this 4.3, converted in terms of A, and 4.604 A over 2 into A. So this is that one plus 4.34A plus 4.64A over 2 into this. Then area 3 is triangular area. that is this area. This area, equilateral triangle probabilities. This is, it is here half into base into height. We have base into height. This is half into base into height. 1.188, 1.118 height, and 1.118a. So you know what it is. So this we get value half base into height, and then area 4 equal to area 2, because we just worked out 3 areas, and then area 2 is equal to area 4. Area 4 is equal to area 2, so we can like this. Area 5 is equal to area 1, so we can use like this. Area 6 is very small area, trapezium, so that's also we can say 1.18 a plus 1a over 2 into this. We can this value in area 6, that is, area 6 is here. It's rectangular. Area 6 is rectangular. 6 is here. Yeah. Sorry, this area 7 actually, by mistake it is 6 here. I said 7 here, and we can see the 7 area. 6 is 7 is rectangular. That is this one. 3.6764 into 8. Some of these areas, these are circular areas, C88 to I, we have taken this. Now, this is area. An area we can find volume, and before that we should have area and vertical surfaces for which parameter is responsible. So we have taken this. You take a move like this, you can say A, 0.26 A here something, 0.236, then 4.4, and then here some other dimension, 3.764 A, and then 3.6 for 4.47 here, and then 2 point something, 2 point something here, 4 point something here, and then you can say A again, and 3.3 something here, and then there. So you got complete idea here, complete measurement here. Exclusion is there. We can find two end area J is here. Total area into depth, and surface area is 2 into J. You can say J plus K. K is this and L is this. So Y is solved. We have Y is gone. After that, nothing is left in reality, so we have to go to letter 1. Letter 1 is there. We have to go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. In also this, we have 2 curve and 2 square. We have 3 curve and 3 square. And we have 45. We have letter 5, which is, I think 3 is already done. We have done 3 here, so we have those 3 here. Okay, letter 5 is here, which is exclusive, and 6 is also curve as well as other one, and 7 is exclusive, and 8 is also both, and 9 is also both. So we go back to letter 1. Letter 1. Letter 1, we have to understand what we have to do here. Letter 1 shape is very, very simple. Here you can see by this small, or you want to blow it up, no problem. It is this and this 3 areas, 1, 2 and 3. We have taken 3 here, 7 here, and we can say 5 here. It's not a big deal. So letter 1 is area 1, area 2, area 3. 1, 2 and 3. Rectangular area is, you can say, this is 3 into A, and then it is, you can say here 3 into A, here 6, here 6A into A, and then 5A into A. So 3A into A, 6A into A, 5A into A. Total is all these 3. And parameter is, of course, we can say, let's say 3A, A, as it is A, 3A, 7A, okay, this way, 3A, 7A, then you can say 2A, A, 5A, A, 2A, 6A, 2A, and A. So we got all here, and that's this. You can see what's written there. 3A, 7A, 2A, A, 5A, A, 2A, 6A, 2A. Now it's over. We have extrusion, volume is area D, area into D, area is, here is area F, F into H, and 2 into F plus G into H. So we have this done. It's simple. 2 is not simple. 2 is not simple. It's different. It's different in a way because of curve. It's like that, It's like that. You can say little different it is, and it is like this, This is that. Little complicated semicircle, and then part of a semicircle. This is a semicircle. This is a part of a semicircle. This is trapezium. This is, you can say, another trapezium, and this is, you can say, another rectangle. One rectangle, you can say, one semicircle, one part of a circle, one trapezium, and one rectangle. We have so many areas in this. So we have to understand this point very clearly. This point is not very easy, but little understandable area, like, 2. Area of 1, you can say semicircle, which is same, half pi r square, and r square, 2a. 2a it is, suppose a is 5, so it shall be 1 in that case, 2a. If it's 20, you can say 20, it is saying 2a, so 4, 20 means, now it's 10, we are saying 2a is 20. If it remains 2a, and in that case you can say 20, you can say not 15. So it will be like that, it change accordingly. We are taking in terms of a. Already we have done it. So there should be no confusion when we are saying 2a means it is, a is directly taken from grid, that is here strip width, to 2. So it works like that. Means if it is 20, it shall be 4, because 4 into 20 is 2a it is, so it is 2a 20. If it is, say, 15, 20 in that case, 2a, that is 2 into 10, 20, 2 into 20, 40, 40, and then it's like this. So area 1, area 2, area 3, we have 3 areas for letter 1. So 3a into a, then it is 6a into a, and 5a into a. Sum of these 3 is here. Then parameter simple, 3a, 7a, 2a. I'm sorry. Oh no. Okay, we take this way. We solve this. I'm repeating for nothing. I'm sorry. I made a mistake. It is letter 2. I have to tell you. I'm sorry. My mind is somewhere else. No problem. Area 1, 2, 3, 4, 5. 5 areas, and area 1 is semicircle. That is here pi r square. So it's that one, and it is pi r square. R is 2a, and then you can say area 2, that is 56 degree circular, means sector, you may call it 56 degree, that is half pi r square into 56 or 180. R is 2a, so this is half pi r square. R is this, into 56 over 180, and you have answer to area 2. Area 3 is trapezium, area 3.5a plus 4.03a. Dimensions are there, you can see a. So we say this is 3.5a, 4.03a, or 2 into that. So we get area 3. And area 4 is also trapezium, which is smaller one, of course. This is 0.469 into A plus A over 2 into this V894. This is that. We get area 4. Area 5 is rectangle, 5 into A. We got this. Total area is sum of area 3, 4, 5, because area 3, area 4 is 5 rectangular, and area semicircle. These are two semicircular, 1 and 2. The both and sum of them is this one. It doesn't matter, just for record purpose. Parameter and circumference is C. Parameter you can see, otherwise you can go and see there if you want to see this. Parameter are only here, here and here. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. One is, this is also there, I'm sorry. 1, 2, 3, 4, 5, 6. And here 7 and 2 here. So 1, 2, 3, 4, 5, 6, 7, 8. That's okay. Here's A, and this dimension 4 point something, then 2A, this dimension 5A, this dimension A, and then 4A, and then 0.5A, and then 3.5. So these are parameter dimensions. These are here all 1, 4, 2, 5, 1, 4, half, and 3.5. We get parameters, and circumference also. We have 1 and 2. Circumference, that is pi r25 plus this 5 into this, additional this 1, 2, and additional this 3 and 4. We have here 1, 2, 3 and 4. One is 5, 2.5 is up to half circle, and then pi 2.5 into this into 56 over that, this extra one, and then you can say internal one, same. We got that. So we have then, you can say volume, which is also H, that is area into depth, and third one is, that is I is curve one, area and depth. We can say then both are here, and then surface is 2 and area plus perimeter. It is rectangular. This is I into M, and then curved semicircle. Yes, curved semicircle. Volume. It is, that is I is circular area, and then surface is here 2 into perimeter. H is rectangular area. We have the surface area 2 and areas plus perimeter into D, and perimeter is here, and that is perimeter to D. We can say K into D M, and also here you can say here, that is for semicircle, and this head areas. This head area is this is I, this is I, curve case, and circumference, that is L is here into T. We got this. So 2 is also over. I understand. You got it. 2, I have to take other 2 also. That's the point we have to take. Square shape also, square shape of, just a minute, please watch this. Meanwhile, it's easy, not difficult. Let me just stretch my legs, because it's difficult for me to sit continuously due to my fracture in leg. Yet I'm trying to give as much as I can't sit longer, Okay, say that. Yes, letter 2 square shape. Square shape letter here. 1, 2, 3, and 4 is straight away. 5 a, 8 a. No problem here. 1 is 5 into a, that is 2.5 into a here. Second one. Third one is 5 into a. You can say 5 into a. Fourth one is 5 into a. 2, 2.5 into a. Then 5 into a. So you can say 5 into a, 2.5 into a, 5a is C90. So this is same as that one. This is also same as something else. Area 4 is a square meter is equal to this. So this is area 3, that is equal to area, this is C900, this is this 500. Hold on. Okay, area 3 is full, so this okay. Area 4 is D, area 4 is D, so the 2, this is fine. Then area 5 is C, and that is area 5 is area 1. So sum of all these areas, and then parameter is starting 5a, 4.5a, 5a, 4.5a, 4a, 2.5a, 4a, a, 4a, see 5a, 4.5a, 4a, 2.5a, 4a, a, 4a, 4a, 2.5a, 2.5a is here, 4a, a. All something wrong, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's okay. Maybe sequence is wrong. 5 is right. 4.5 is right. 4 is right. 2.5 is right. 4 is right. 1 is right. 5 is right. 4.5 is right. 4 is right. Then 2 is right. Then 2.5, sorry. Then 4 is right. No, it's okay. Sequence is also fine. So 5, 4.5, 4, 4, 5, 4.4, 2.5, 4, 8, 1, 5, 5, 5, then 4.5, 4, 2.5, 4, and 1. So it's okay. Extrusion is this, then plan area is then now take this area, that is A, total area into 10, and 2 into area, again we say H into this and H into that, half I. So we have done 2 square. Now 3 curved, difficult one. Takes a lot of time. This is number 3, letter 3, breaker, it's really breaker, you can say. It's big one. Big one means you can see first of all how we are designing this. First of all, we should understand that. You can see, you may not see completely, but it is semicircle and semicircle. It looks very nice by saying that. Yes, it is semicircle and semicircle, but it's difficult to understand. One area, 2 area, then you can say this is 3 area, and this is 4 area. 3 is complete geometrical curve, and this is also same. 5 is easy, again 6 repetition of 2, and 7 is repetition of 1. I'll just blow it. The AutoCAD drawing I have shown you already, so no need of confusion. We showed to you that, so you can see, in this various trapeziums were drawn. And let me just show you if you can do more by just little ball drawing. There's no space actually. If you can say little drawn up, you can see many trapeziums are drawn here, integral of 2 meters in this case, and some small triangle here, a small triangle here, and then here also another one. And this is remaining dimension. All dimensions are given there, and we convert them in terms of A. And here problem is this angle, subtending angle on these three curves is very important, because these angles we have to use 34, 34, 37, that's 33, 34, 37. So average if you take them is 30, 35. So it's that one. So I just put it off for 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 your purpose, and let us now go through what it says. So, it looks very critical, very complicated dimensions. I think this is the most difficult one in this case, number 3, and also number 5, and then number 6, and then of course number 8, number 9 too are that. So let us patiently think of what is this letter 3. Letter 3, this is that one. I think we have to just adjust dimensions if possible. I think it is maybe this. Let us pull it back to minimum 1 if it can be. Area 3, it can be. I think no, it's more. Oh, it's okay. No, it's like this. You see, you can say 3 area. No, there are curved area 1. That is this. Square meter is a semicircular pi r. R is 2a. Curved area we are taking, then you can say pi r. That is r is 2a into same 906. So this is first one is AC. That is semicircular curve. Either we take difference of two subcircle, or we take directly axial length into step width. It's one and same thing. Then we have to consider area 3. That's we have no, 2 is still there. Sorry. This is we have taken angles there. Area 2 that involves angle. This is, you can say 37 plus 34 plus 34 or 2 or 3 degrees, average of this. And circular is equal to pi this into 180. Circular, this is degree circular, way to find this, and that is pi r plus 33. You can say 37, this average into this. You got my point? Yes, you can say here. We have taken this. This is number 1, and this we are taking number 2. That's what we are saying. So it is curved area 2. This is 37 plus 34. This over 3 degrees circular. 3 is so many degrees circular, and that is pi r. First of all, we are taking pi r. That is half circle, and you can say, well, I think sometimes confusion exists in whole one. Area 2, it says we have, I can't show you actually that AutoCAD, unfortunately. That day I showed to you, explained to you that one. It's saying this is, semicircle, and this is area 2. These 3 points are having angular trouble, because we have to use them, and this is an angular trouble. If you can see this side here, you will find this and this, and we have to calculate this as well as we have to calculate this, and that's what it is. So let's say angular degree of these 3 points, that is sum of this 3 over this pi r, and pi r is, if you see here, It's very complicated, this question actually, very complicated this one, because we have to ensure this angle, and this angle is here, we are taking this portion angle here, in this case from here to here, from here to here, like it is here, this angle is here. The difference between this point and this point, we are taking this point and this point here, same, means this whole arc is covered in that. So we can say that what we have taken here, let us see what we have taken here. In this case is pi r this, pi r, let's do this, and minus this one. So point to be considered, and you can see difference also here. Curved area, half curve area 620 point this, and we have seen here, we have worked out here this curved area, first one, that is 628.3. You can say this area we have curved here, this is something like this here. This one here, other one is this one. Right. So we got 75 here only. If you see this one here, pi to a, r, that is pi r, plus pi r into this degree, and this is this. Here it is 61 pi to this into this. It's direct 60 pi r into this 906, and here it is pi to this plus pi this into that's what confused, not plus. I could not do it correctly. That is pi into 2 into this value over 3 over 180. 75.05. It's coming like this. Area 3 is trapezium. It's also length calculation. We have to be very difficult calculation is this. In minute we have to see pi to pi. For example, we are saying trapezium. How many trapeziums are there? You can see these trapeziums are there. These trapeziums are there. You can see this. Similarly, here we can see trapeziums. We are copying that. We are copying here. We are copying here. Also, we are doing this. You can see. So it's same one. So we are taking here. To rectangle, we are saying this one. So we have to understand. Maybe I'm wrong. We are saying pi 2 into this. How it can be the same one? Pi into 2 into this. Pi into 2 into this. It's coming same. Pi into 2. Pi. Okay. Pi into 2 into this. And there's a double one. We are saying pi into this into this. So pi r into a here, and here it is pi r. There is a difference. Pi r. It's not area's curve length. I see that. It's curve length. Pi r. It's not area. There it was into a. It's a difference. That's direct area. Pi r into a, and here is only pi r. Pi r means 2a in middle. It is curve length plus pi r into this average 37 plus 34% or 3 into this. Why should class? I made a mistake, I think. Should not made a mistake. We are taking or it should be curve length only, not other one. We are taking up to here, up to here. We are taking up to here. This angle we are taking up to here. So pi r, I think this should be curve length only, and not this should be different. Only this curve length is important here. So what we should do, maybe pi r into this. This is subtending angle. This sum of this angle over 180. Oh, yes, that's right. If you just make let me see if we make a point here. Let us see some here. This, just a minute. I think this is 12 point or something. Let me see. 12 is say this is into 10, 120. So I think that's right way. We made some error here. I think we have to correct this one. Some error was there. So it is pi r. Pi r, that is half circle length. Pi r. Pi r, we have to find this half circle length. And this is multiplied with subtending angle of 180. I think now we understand. There's some error. So pi r multiplied by average of angle divided by 180. So we get this value, which is now okay because 120 into 10, so 120 this is okay. So it changes every year. So apologize for that error. And now it's trapezium. This trapezium, which are area 2 and that is here, area 1, area 2 is here. Area 3, this trapezium, area 3, area 2 was this. Area 2, area 3, area 2, alright, area 3. Now, area 2 was curved one, area 3 is trapeziums, area, there are so many trapeziums, you can see here. One is this, then you can say, and other plus another one is here, you can say, let us see here, this plus this or 2 into that one trapezium, and this is another one, this continuation, another 2, and this is other 5 continuation, this is another 2 into this, and this is another one continuation of this 548 into this, and plus on this, and this is this one 53, and this is 2.9. All right, this is here. I will confirm it again. Let us see. Let us see here. Oh, sorry, not here. Let us see here. First of all, 0.753 into this plus 0.67. This is two different dimensions of trapezium, up and down, parallel dimensions, and over 2 into 0.1. This is because we are taking 1.1 B906.1. Also I'm taking here 0.1, and also here I'm taking 0.1. So it's 0.1, as we say. You have to see 0.1 here, and we have to see 0.1 this. 0.1 is, and also here we are saying this is half into base into height. This is different. So we are taking here, it's written here 0.1a. Here also written 0.1 is there. This plus this over 2 into this. So in pi 3 is this, okay. 6.74 plus this over 2 into a because this width is down, 0.1 is 1 meter and 3, okay. And trapezium 4, all right. we have to see that actually I don't have that drawing. If I open, I can clearly say if there's an error, we can check it. If there is no error, we can see that's okay. But here, no problem. Maybe this is dimensions we are getting from there. So we get this trapezium area here, and the other trapezium area 4 also is same. So we are taking equal one, but dimensions are there. If I can open that drawing, I don't exactly remember where that drawing is. I showed to you area 5 is here now. Area 5 is here, that is this one rectangular area. Area 5 is not a problem here. Area 5 is not a problem here. Area 3, area 4, we got area 5 is here, and curve is there. This curve here, area 6. Curve is there, that's area 6, this area 6. And this also curve as the area 2 and area 6. So we have similarity in that area curve. We can say, okay, this is our same as cos 7 is 1. So we can say that we have this. I'll confirm about this area trapezium because now I don't have trying. Or maybe if I open this, it will waste time. Let me see if I can open this. This trying also is kind of we have to see whether we can open this trying. It will take some time, and I don't want to waste time actually. Let's see geometrical here. This is geometry here, and we can see this geometry 1. You can see here 3, maybe it's somewhere here, and sorry, this is let me see if it is there. If I can find, I'll confirm just now. Sometimes it's very complicated work, and it's taking time also. No problem, there's no problem. We'll see what to do. You may have to patience. We should have patience in this regard. Oh, come on, open. Because it's CAD trial 1 and it's already expired. Take some time. Oh my God. It's coming, try, and now it's coming. Let me see what is 3 is there and all this other trying then. 3 checks is there, no. Come on, open. They are taking 2 times tangent. CAD is slow, why is slow? Too much time. Oh my God, I'm wasting my time. I'm wasting public time also. So this is not on this trying. So let us go to see some other here. Let us open other drawings and see how it works. So let us say this. I think this is 3. I think that this is 3. Yeah, same is 3. Let us see the one this. Let's see. It's 3. It's 3. Yes, it's 3 is open now. This plus this. I think this is 1 here. 1.09 is triangular area in height. Alright, so let me see what you write. I have this ordinates here. Let's move together and see what we have done. It's a check also if I done right or not. 0.753, 0.753, 0.753, 0.674, 5.86, 5.86, and then the 4.88, 4.88, and then 3.78, 4.88, and then 3.78, and then 2.53, 2.53. So it's 2.53, and then it is triangle as 1.01. So half into base into height. It's okay. Half into base into height, and it is here. You can say here, yes, these ordinates are okay. 1.09 triangle into 1, 1.09 triangle. This is here, and 1.09 triangle is there. Then it is 0.067 also, 0.067. So this is 0.067. That's okay. Triangle is okay. And I think this is 1 meter or 2 meter. Let me check it. DI. This is 1 meter or 2 meter. This is 1 meter distance, so it is 1 meter distance actually. So I have taken 1 meter in this case. So it is 1 meter, so 1 meter is okay. Oh, because this is a very small curve, so I have taken 1 meter. I forgot in fact. So it's right. This dimension is right. There's no error in this. We have to accept this and also accept this. So these are all okay. There is no problem. There was an error which we corrected here. So curved area we have same, and this total rectangular area is this, semicircular area is this. That's all we have to say. This is all fine. And just a minute. Just a minute, please. Just this area is very important one. We have to see. Hold on. So we have covered areas for 3. All areas are covered. Now we'll go to we have fraction here, total areas, rectangular, and total areas semicircular. Some of these areas are here, parameter. Now we have taken upper and lower. In this case, here it is upper and this is lower. This upper, this is lower, and we have to see how it works. Now parameter upper and lower is a plus 1.667, a plus 1.247, a plus a plus a plus 1.247, a plus 1.6, a plus this. This is all there. If you want to see there, you can see that. This is a. All these are measured here. All like this is measured, and then this is. You're done. Then and it can say 1 plus 1.67 plus 1.247 something. We 1 plus 1 and 1.247, 1.67 into this. So we have done this. Circumference also similarly in this pi r we have to use pi r 25 like this, and in terms of that we can say pi 2.5 into this, pi this into this. Here we added that value 2.5 to this r over this plus pi into this, and we got all these circumference here. And lower circumference also similar. So total circumference is this. Now we come to extrusion. Plan value is here j. This is rectangular areas into depth, and this is curved. This is curved areas. This is curved areas here I. I'm sorry, this is I or what? Since I'm a circle, this is curved areas. K it is saying total semicircle area also here 1 2 plus 6 1 plus 2 plus 6 plus 7, and that is total area of semicircle K into Q. Q is here, that similarly we say this is J, so this is J into this plus MQ, and M and Q are here parameter, and here also this is J, this is K, and this is K. 2 into K into P, and that is here circumference is 906 into Q. So we got complete done. So this is very complicated. This is 3, but we resolved it. We resolved 3 already. It's 7 o'clock. So we go to 4. Letter 4. Letter 4 is very easy. It's ordinary letter, you can say. 4, I don't know, 3 actually it should be. I don't know how 4 has come in here. Well, it has come, no problem. We'll respect it. If it's done, no, not at all. It's a letter 3 here and 4 here. I think adjustment problem. Actually, letter 3 let us consider first. This is 5A, 8A. 1, 2, 3, 4 actually. 1, 2, 2 is whole down, 3, 4. So it's simple, area 1, 2, 3, 4. 1, 2, 3, 4. 1 is 5 into A, 5 into A. 2 is 6A into A, because 5 you are taking, 5 here you take, 6 it is balance. 6A into A. Then you can say area 3 is 2A is balanced into A. And area 4 is 5 into A, 5 into A. So we can say same way, 5A into A, 6A into A, and 2 into A, 5 into A, the same. And total is 1, 2, 3, 4. And we conclude this area. Now parameters, let's say 5A, 8A, 5A, A, 4A, 2.5A, 2A, and again 2A, 2A here plus A plus 2A plus 2.5A, and here 4A and A. So that's okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's okay. Extrusion is this. We can say area here is G. So this is G into I, and here it is 2 into area, 2 into G plus H parameter into I. So 3 is done, 4 is there. Let us say, maybe I don't know why 4 has come back. It's also same 1, 2, 3, 4, 1, 2, 3, only 3 areas. 1, 2, 3, 5. Well, say 5 this way into A, and 2 is in between. So we get 3 into A, 3 A into A, actually not 3 into A, 5. Actually 5A into A, by mistake is left. 5A into A, 3A into A, and you can say 8A into A. 8A into A is that one. So 5A into A, 3A into A, 8A into A, 1, 2, 3. This is all C to E, and we can say parameter. We can say A starting from here, A plus 5A. A is A plus 8A, that is, A, A plus 5A plus 4A plus 3A plus A plus 8A plus A plus 4A plus 3A plus 4A. So it's done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 into 3 into 5, 5, 6, 7, 8, 9, 10. Now area here is 16, this is F. So F into H, F into H, and 2F into GH. G is this and H is this. So it's done. So area 3 and area 4 have gone. Complicated area is 5 here. 5 area. 5 area. See, this diagram is also very complicated. It's not easy as you think. It's complicated one. we have to understand how it works and how it's working. And this is, you can say, already 1 and it's 26 minutes, so 16, 17 minutes recorded last video. And this is made like that. This is a tangential correction here. This is trapezium, this one is trapezium here. And either you take this, we'll see what 1 and 2 and 3 and 4 and 5. It's 1, it's 2, it's 3, it's 4, it's 5. Subtending, although I think, I don't know, actually it was 30, but this is not clear from here. No problem. Let's go and see how to do it, 5 here. And then we have to see how 5 works. It is here, 5. So I keep it little, or I can say I can click it down. So it says 1, 2, 3, 4, 5. 1 is trapezium, this is that. 2 is trapezium, this is that. 3 is here. 3 is trapezium again, and 4 is curved, and 5 is curved. Right? It's exactly what we did in number 5. So here is trapezium. That is, this dimension is 4a, and this dimension, that is 3.2, or whatever is there. 4a plus 3.261 over 2. This is a, of course, 361a, whatever it is, and it is 3.261a. Yes, it's a. So this is a. Sometimes a is missed in writing. It's only for education here. And this is what it is. 4 this value plus 3.261 this value over 2 into b. All right. Area 2 is 3.413 plus 1.643. A again is missed here. That's why sometimes in writing it happens. You miss something, but in formula it's okay. 3.413a plus 1.46a over 2 into this, right. Area 3 is also trapezium, and it says 3.002a plus 1.961. I think I assumed as written. That's the problem. So this is 3 into this value plus 1.961, all it is. Okay, fine. Area 4 is curved 1, pi r into 75 degree angle, that is, it's saying 75 degree angle. So pi r, this is pi r into 75, pi r into 75 over 180. This is that one, because the part angle it is, part curve it is. So if you take 75 or 180, you get real length of curve. Area of curve 5 is full half circle. So it's simple that it is same formula, pi r, got this value. And area 1, 2 and 3 are trapezoidal areas, so we got 6 knee, and area 4, 5 some circular area or curve area. So we got this value. Now trapezium value we have to add, and curve separately we have to add for purpose of, this is for purpose, this was for trapezium. Here we have to see 1, 2, 3 trapeziums. So 4a, 4a, what value is it? 4a, 3a, 4a plus 4a plus, this is parameter, 4a plus this value, plus this value, then this value, plus this value, plus this value, and this value. So 4a, this 4.413, 3.203 a 1.971, and then you can say 1.63, and then 3.26a, and then a 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 dimensions. You can say 3 are here, 4 is here, 5th is here, 6th is here, 7th is here, 1 is here, 8 dimensions. That's okay. 4, 3.413, then 3, then 1, then 1.971, then 1, 1.971, what is that? 1.63 something, and then 3 point something, and then 1. So we got it. So it's done. It is 94. That's okay. Extrusion is 10, and plane area is now H is area, I think. H is plane area or trapezium area. I can say plane or trapezium area. We can say trapezium area, right? So it's that one, right? Then curved semicircular. This is I is curved area into. Alright, that's okay. L is there, so fine. And in this case, surface areas we have met. Surface areas H2 into H. Surface areas 2 into H, that is this area, and plus this K into L. Surface areas to area parameter. I think we missed some, or is missing, or we have taken that. Let me see, maybe we missed something. Surface areas we have taken and area plus parameter D curved surface. I missed something. I think missed curved area here. That's not good. So parameter we did here. We missed surface area. Trapezium volume is this volume. I think this should be circular area volume. I think by error this is missed. So we should correct our mistake, and that's also important. Parameter here, and this is so it is here, you can say plane curved semicircular. So third end area circumference. So this is our curved area, you can say here. Let us copy this and adjust. That's not a big deal, it can be done. Sometimes we miss some things, and in this case we miss this one. So we say curved surface, two end areas. Two end areas are here. Volume is because of this area of I-94. So this is I-94 plus K, and it is how much is K? K is curve, so it's okay. It's K into L, so this is done automatically. So that's what we did. I think we've done it. No, why it's coming? No, wait. Maybe something wrong. Okay, this is area into 2 and 2 into I. I is curved area, that's fine. This is curved area plus K. K is circumference. So this is right. K is circumference of this, and L is depth. So this is okay. Okay, 30.09. This is fine. We have done it. So something was missed. We have covered it. We have covered that one. So this happens, and it's complicated. Volume is calculation, and sometimes you miss. So we did it now. Thanks for your patience. We did it. Now we come on to letter 6. Letter 6 is also having trouble here. It says this curve, and this is circle, and if we consider the circle hole, then this is a trapezium. It's also curved one. This problem, you have to understand this curve as well. I show you in diagram, in drawing 6. Now this drawing is not having 6, so this is not having 6. So this drawing can be closed, or no, it's not having 6. Okay, you cannot see this drawing, but I can open other one as well. From this drawing, if I can open, I can say, I think command has to go first. Yes, this has to go. So 6 is here. 3, this is 6 is not here in this. Also not in this, not in this. I don't know which one is that. This is this one. I don't know. This is maybe this. Let me try. Push this one. Oh yes, this is 6. I am able to open 6. But it's not full 6. Where's that 6 I was searching for? Let me open other drawing as well. Some error here. So it's this. No, it's not there. What is that? Yeah, I got it. This is another full 6. So other one was not 6, I close the other one. There's no need of that one. There's no need of that one. Okay, 6 I have this. This triangle also I close because there's no need of this triangle. Oh, okay, I close this triangle as well. So I got 6 here and other triangles 1, 2. Okay, so I have 9 here, so I'll use 9. So drawing 6 is here. Alright. In this I took area 1. You can't see this, but I can show you. Area 1, then area 2. This area 2 I converted area 2 into a trapezium, and from that curve area between uh, circumference part and this connection of 2 points, and then we did area 3, that is, and that is we deducted from that. This is what we did in this case. In this case we did that. So let us see how it works. It's area 1, area 2, area 3, area 4, and these are 4 areas. You can see area 1, area 2 is a very complicated area, and area 3 is this area, and area 4, this is this area. Area 1, it is a half semicircle. It's half of a circle, pi to r. So it's same answer, pi to r into this. We are just taking in between, that is 2a. So we got this answer directly. Then we can say trapezium area 2, which is trapezium 3a plus 1a over 2 into a. So we got this area of trapezium here. This dimension here, we got this area of trapezium. Now from this trapezium, what we have to do? Area 3, that is 2 number triangles. Area 3, if you divide this area into this division, you can say we divide into various trapeziums by offset of 2, I think, as in this case offset 2. So we have to divide, answer is, then we have to 2.64, 2.56. This you can say you take 2 point, which we are taking here, let us say, we're saying half into base into height, that's triangular portion, then 0.55 plus 1.2, that's and 1, that is of course 0.55, 1.30 from other end, and 1.32 and 1.291, and there's other one, and then like this, so it is 1.91, 2.23, and 2.23, 2.56, and 2.5, 2.64. So let us check our calculation first. What it says, half into base into height, that's triangular portion. That's fine here. 2 triangular portions. Sorry, I'm taking 1 here, and here I'm taking 0.005 because this continues for 1, and 132. That's okay. 132. Then 132, 191. Then it's, you can see 132, and this is 132 and 191. And of course, when talking divide by 10, of course, and then I can say 191232 here, and that is, it is 191232 and 232.6, 232 and 232, and here you can say 232 and 256. It's okay, and then 256, 264, and of course this is done. So this is multiplied by 2, and of course division by 2 and multiplication by 2, because it's 2 meters offset, not 1 meter offset. So we are getting this answer. This is area 3, and we say that this is area 3. Area 4, this is area 4, and that is half circle, 2 pi r. So this is okay, half circle is there. Now sum of this area cannot be done because area 1 plus 2 minus 3. This area we have to deduct. This area we have to deduct area 1 plus 2 minus 3. So 1 plus 2 minus 3 plus 4. So 1 plus 2 minus, we get this area. That is total area where curve has been taken out, curve sector has been taken out. So parameter areas are here. Parameters, this parameter trapezium, that is B3 plus, that's okay, that's 1 trapezium. Now this is trapezium parameters, and you can say have this, you can say parameter this one and this one and this one. 3 parameters are here. This is so simple, a plus 3a plus 2a, a plus 3 plus a, and we can say then circumference. Now this is important point. You can say, if you see pi 2.5 r by r, 2.5 r here, what is 2.5 r, pi 1.5 r, and then you can say 1.5 there, and you can say 2 pi, then other one, here you can say 2 pi we are taking here, pi 2 pi r because of this portion, and minus 2 pi, this angle subtended, this portion reducting, minus 2 pi to this into 53 hour. This is 53 hour. 360, we have to have whole line this, and plus 2 pi r. So we got this parameter, this circumference done. So extrusion here is 10, and A now is the area, rectangular area, and that is here. This is area 1, 2, 3. This is area G, and we can say here it is G into this, okay, G into this, and we can say that here surface area, and this is 2 into G plus H, 2 into G 930 is 930 plus parameter H 930, this is parameter, into D plus I 930. I 930 we have taken circumference in this because it's very small. If composite, we have taken one hole. We have taken one. Here in surface area, we have taken all these very small. It's very small. We have taken hole into this, and of course internal circumference also internal external here both. So we have taken. You can say here circumference is pi r 2.5 r this one, and pi deduction pi r into this plus 2 pi r into this plus minus this and plus this 2 pi 1.5. So we have done this 6. This is a complicated calculation, and of course 6 is here, that is square 1, just to support our calculation. We have taken 6 also square 1, and this is here. It's not a big deal. This is not big issue. It's simple one, and it is 729 or 7.5. I can see still we have to go 7, 8, 9. No problem. I'll try to complete it. I'm tired. Sometimes you have to concentrate heavily on this. You have to concentrate heavily on this. Only then we can say what's right, what's wrong. Heavy concentration is required. You can say here. So 6, 1, 2, 3, 4, 5. Though it's simple, but it's not that simple. We can say area 1, this is area 1, 5 into A. Area 2 is this, in between. You can say whole taking it from here to here 6. 6A into A, and then 3 is in between, I think. 4A into A, and then area 4 is 2.5A into A. Then area 5 is 5 into, this is 5A. In total rectangular areas 1, 2, 3, 4, 5, all are rectangular. So C to G, C to G. Parameter, let us see, 5A, 8A, 5A, 4.5A, 4A, 2.5A, 2.5A, 4A, 2.5A, 4A, sorry, 2.5A, 2.5A, 4A, plus internal. Okay, let me check it. Let us say, like 5A, external 5A, 8A, 5A, 4.5A, 4A, 2.5A, 4A, A is external. Internal of 4 are there, so 3 and 2.5, 2.5A, 3A, 2.5, A, 3A. Here also I am writing A, so I write it now. So it is that 5, 8, 5, 4.5, 4.5, 4, 2.5, then 4 and 1. then 2.5, 3, 2.5, then 3. We got this. So this end you can see area is this one, area is h into j, and it is end, two end areas 2h plus I is perimeter into j, that is this one. So we got 6 solved. 7 7, because 7 is not direct shape, it is it's inclined shape, and we have to have all the dimensions in terms of a. Here it says 1, 2, 1, and then 2 trapezium, 3 trapezium, and 4 3, and I think 3 is a trapezium, but there is a, how this 4 is also here, and it's 4. I think it's not written correctly. It's 4. 1 is a rectangle. This is 5 into A. Second is trapezium. This is trapezium. Second, there's A plus 0.6 something here, or or 2 into A, that is 0.6 there, into A, and 3 is also trapezium. That's trapezium here, and there's 7.21 here, and over equal this, and what is okay, fine, is okay. A triangle here, actually this is a triangle. I by mistake it was a 4 one, so half into A into 3.303. So it's okay, this is 4 actually, this is not 3. Now I don't have 7 diagram here, so I can correct into no, it's not here. I'll correct later on that, it's no problem. So we got here all these areas except that, sorry, 7, 1, 2, 3, 4 areas 1 plus 2 minus 3 plus 4. I'm taking 2 minus. No, it's not minus, it's all plus. So here writing is error. So it is it's copy plus problem. So it's same CF, and then we can say parameter. Let's say parameter like B is written A. It's A 5A, 2A, 7.2 something, A 0.3 something, 0.00, then 7.2 something here, then 0.69 here, and then 4A. So it's okay. So B is 1, 5, 2, 7.211, 1, 0.303, 7.211, 0.697, and 4A. So it's fine. And we can say area is here, that is G, I is okay, 2 into G plus H is that, into I is okay, 7 goes away, 7 goes away, 8, it's problematic, 8, real one is problematic, You see this, you can see this, 8 carved whole circle, and then there's only cutout. Cutout is also there at an angle of 96. Cutout is there at an angle of 96. So A1 is here, you can see 1, 2, triangle, 3, in between this connection of the 2, and then 4, which is same as this 2, and 5, which is same as 1. And these are the same on one point. R is this, and R is this. That is, we'll take in terms of A. Got it? 1, and angle is 96 here. 2, 3, 4, and 5. Let's do it. If we finish today, it's fine. Otherwise, we have to wait What's time now? Let me see. Its time is, it's exactly 7:36. So it will take another 10 minutes, I think. We complete that. 8 area 1. This is part circular. Area 1 is part circular because this is not circular, part circular. Okay, so it is part circular, and pi 2r into a, and then 36 minus 90, 360 minus 90. This value which you are taking, 360 minus 90 over 360, you got my point. We'll get exact value of that. The subtending angle is 96. So pi 2r, 360 minus 96 over 360. So we'll get exact value, right? We get exact value of this area. Pi 2r. Pi 2r is not area, right? Is it? Maybe I made a mistake. Pi 2r. R is that 2 is pi 2r. 360 minus 96 over 360. But where is a? I think I made a mistake. I did not multiply by pi 2r into a. Here is okay. I have written here pi 2r into a. I wrote a, but there I did not. Pi 2r. I did not write here. I should have written. Well, I do it now. Into a. Into a. So this is that one. So it is changed now. This is what happens sometimes. You do not miss some point in Excel. Pi, again I say, is full. So 2r, r is this, and to subtend the angle, the difference, and so this, okay, fine. Area is now okay. Is it 2r? Hold on, 2r. This middle one, let us see, maybe another mistake. No, it's okay because it's okay, R15, so it is in between two. It's fine, it's okay. Now, another area 2. Area 2 is a triangle area. It's triangle area, and I take this one. Just hold on. This is hold on. S minus C, S minus B, S minus C. हाँ? वो ले गया है दुकान वाला। काफी देर हो गई। क्या हुआ? तो दुकान को लेगा। वो मुझे बताई। मुझे बताई। क्या दी? अब क्या करेगा? अब कोई बात नहीं है। आई क्या? लेकिन मुझे पता नहीं मोटी नहीं होने लगी। आई तो थी कोई पता नहीं मोटी नहीं होने वाली। आई तो थी। I'm just drinking some water. Give me some permission about that because I'm taking my medicine. Taking my medicine, start drinking water, and I just take another 5-10 minutes to complete that discussion. Okay, fine. I just take some water. Alright guys, I'm going to take now this So error was discovered in A, and now it's now 8 talking, 8 real, 8 real and area 2, because taking dimensions of uh, triangle sides means S have to calculate, and S we have to calculate, and we have to calculate then S minus A, S minus B, S minus C. As usual it happens in usually the area formula of a triangle when we use 3 dimensions triangle, no angle. Okay, I've taken the medicine. Right. So triangle S into S minus C into S minus B into S minus C under root. That's we call it under root. uh, it's there in formula, but I think it's missed somewhere. S minus A S minus C. You see this triangle. Actually, this is power. This is area 2 is it should be correctly depicted. I missed that one as well because there's some problem. Excel cannot use this, so I say let us say, or let us use another bracket here to be very clear about difference. Let us say this bracket and this bracket here is better to give a power 2 exponential 2 here and 0.5 actually 0.5, so it can be, we can see now it's right formula. S is equal to A plus B plus C over 2. A plus B, A plus C are sides of triangle. This is written here. So we have to say, you can say here S is equal to here 10 plus 10 plus 1.4, 10 plus 1.4, because 10 is base and angle of 45 there, and we can say, you can chart this. You see this angle, let's go and see this angle. वो गंदे थे ना, मैंने भारी रख दिए, बाहर के है ना वो, अंदर के नहीं है अब. So this is 10.14, this is 10.14, this is 10. So this is not equilateral triangle, it's isosceles triangle, you can say 10 here. खराब तो नहीं जाएगी बारिश से? बारिश से खराब तो नहीं जाएंगे? अंदर कर दिए. So it is here, we can say this is 10 plus this over 2, so this is 15.4. We have all this 15.4 with this value. So we can say here this value is E948. This is S. We can say S, we have to take it into our value of A. So we have to divide by these values. We have to divide this cell by this cell, B948. So we then say, so this is actually S now in terms of A. So E948 over this, again we have to go S minus A, this is 10. S minus A, this is 10 in terms of A. Again S minus B, that's another 10. And then again S minus C, and we can say under root 0.5, and then into A, S minus A, S minus B, S minus C, under root, and into, you can say A, S minus A, S minus B, S minus, hold on, S into S minus A, S minus B, S minus C, under root, whole under root, that's okay, whole under root, and whole under root or under root, S, just at least S into S minus A, S minus B, S minus C, this bracket closed here, and this bracket closed here, all is covered, that's okay, under root, so all is taken under root. Area of this triangle is, is known here, area of this triangle, you can say it's known here, and then B948, into B948. Yes, just to convert that into terms of A, you know, it's in term into this is not in terms of, I think this is in terms of A, right? It will come same because, let us see how does it work. Hold on please. Oh, no. So this, okay, fine. This is to convert into square meter into this because there was conversion. It's okay. 40.4a. This should be 45. If just measure it, I measured that one and it's coming. Say, if you say 10, let us say 10 or something 100. So it is half into base into height. You can say half into base is 10. Half into is 5. So it's okay. It's coming right. So we are just converting that into checked squares. So area 2 is known, so that's why I said it will complicate it. But don't worry. Area 3 is rectangle. Area 3 is rectangle, is it? Yes, it is rectangle. It's plain rectangle, doesn't matter. So it is 2.236 into A. That's fine here. It's fine here, 2.236 into A. Okay, 2.236 because that is 22 point something. Yeah, it's okay. So we have taken this. So area 4 is, I think, area 4 is same as area 2. So it is plus area 2, or I say actually plus area 2. It's plus, or you can say plus in this formula actually. It's not exactly plus, it is equal. Area 4 is equal to area 2. And let's be sure again. Area 4, it is area 4. 4 area, yeah, 4 and 2 are equal. So it's okay. 4 equal to, actually it is not plus, it's equal. This is equal, area 2. So we just link it and that's D948. Area 5 equal to area 5 equal to area 1. It should be not 5. Writing error. Area 2, area 5 and area 1 are equal. So you can say area 5 equal to area 1, not 5. Again I say, writing error. This purpose is here to talk to you and just correct also part circular this is. And we can say same formula, but only here we have to say area 1, that is this one. So rectangular area 2, 3, 4 is 2, this is 3, this is 4, and we say D948, F948 and G948, and then circular areas are here C and H. So we got this. So perimeter rectangular, we have to see now what perimeter is there. This area rectangular parameter is this, right? There's nothing else. This is 2.236 and 2.236, that's here. Circumference 1, 2 and 2 this side. But this is not full, this is at an angle of 96. We have to be careful. So what to do? We have to see 2 pi r. 2 pi r. That's okay, full. This is full circle. Minus 360 minus 96 minus 360 minus I think maybe hold on over 360. Yes, 3 minus we have to deduct, so it's minus its perimeter outside. It is 2 pi r. This is whole perimeter outside minus this portion. 360 minus here or multiplication here. This is, I think, some error. Multiplication should be right. Just think of this formula here. This is full circle and we have to deduct this angle from this 96. If we deduct this angle, then if we deduct this, I'm deducting this angle actually. So this is 360 minus 9. No, it should be 96 only. Deduction 96. This is the whole, so it should be 96 only. So that's what I say. Sometimes errors are immense. 96 over 360. And similarly here, other one is also same. This is 96 minus 96 and leave. Again we check 2 pi r. 2 pi r is full. 2 pi r is full minus 96 over 360. 96 is subtending, we deduct this one, this portion of it, that full one. In same also. Okay, so I think it's okay. Let's now see result. So this is coming 250 and previously was 249. There's not much different anyway. 250, not 249, so 250 is right, I think. So we got it. So previously we said 360 minus 96 over 360. There should be multiplication one, in fact. Let me check it better. 250 for something, 250 point something. Let us see if I multiply that, what result would be. Oh, no, 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 no. Not multiplication like this, sorry. Not 360 minus 96. And here 360 minus 96. Isn't just a check. And it's multiplication here. It's multiplication here rather than this. And it's multiplication here rather than this. And we see how much is this. 184. 184. No. It's okay, I think. We'll check it again, no problem. We'll check and let you know. Maybe sometimes by doing fast work we can. But 2 pi r, this is circumference, whole circle minus 96 is this right formula. So this we keep a note for the timing. Now rectangular volume, rectangular area is I, so is I into m. Is okay, and this is part here. This we can say here. Total area is this. This is j into that, 2 into j, that is here. And this is I, and this is j into m, that's fine. Then 2 into j, 2 into I, that's I here, 2 into I plus k into m, k, this is rectangular, m is that, and here it is j, L into m, L is circumference, so this is okay, fine. We resolve 8. Now let us say 360 minus that. Hold on. What I did there? 360 minus, but we deduct from that, right? Hold on. Sometimes, you have to confuse yourself. What I did here actually, what did we there? We did minus 96. Now, before deduct 360 minus, no. That's not, 96 is okay, minus 96, what is it? This angle is 96, so 1/4, about 1/4 is to be deducted from this, so this is okay. All right. Now 8. 8 is square one, so there's no problem. Areas dimensions are different, but 1, 2, 3, 4, 5, 6, 7 areas are there, very, very clear. You can see that 3.5 is here, 4.5 here. So we can take it in fast mode. 1, 2, 3, 4, 5, 6, 7, and 4a into a, 2.5a into a. You can just keep diagram with you so that you can see clearly how it is. 2.4a into a, number 1. Number 2 is 2.5a into a. Number 3 is 5a into a, full I taken. Number 4 is 2.5 into a. Number 5 is 5a into a. Number 4 is 2.5 into a, and I'm sorry, number 6, and number 7 is, number 5 is 5a. Okay, the 5, 6 is this, 7 is 7 is 2.5 into a, and rectangular area, so it's all rectangular. So this is from C to I is this. Now parameter we can say here directly 4a, 3.5a, 0.5a, 4.5a, 5a, 4.5a, and 0.5a, 3.5a. And internal 4 here, that is 2, 2.5, 2, 2.5, 3, 3 and 2.5, 3, 3, 2. So it's okay. So we have to go here 4, 3.5, 0.5, 4.5, 5, 5, 4.5, then 0.5, and then 3.5, and then 2, 2.5, 2, 2.5, 3, 2.5, 3, 2.5. So it's okay. Now we say plane area is this J, so JL is okay, and 2 into J and KL, K into L, that's okay. 8 square is solved. 9 real shape. Oh my God, 9 real shape is complicated one. You can see that. It's you can see how it is working, but don't worry, same pattern it is. It's not much difficult. It's same pattern. We have here one full minus this, 2 and 3. Not big deal. Dimensions are there. We can move. Here we have angle here. Some angle. We will see how much is that. So 1, 2, 1, 2, and 3. There's calculation of 2 here. There's 3, and I think 3, and then it is, how many areas are there? 3, right? 1, 2, and 3. Okay. 1, 2, 3. What we did here, area 1 is circular, right? Area 1 is circular. Area 1 is circular. 2 pi 2 r, 2 pi r, 2 pi 2 r into A, and that is 2 pi 2 r into A. We got this area. We are taking middle one, that is 20. So we have no problem. Then 2, we are taking trapezium area. This is trapezium area 2, but this arc is a question. We have to work out arc. So in this trapezium area, we are saying this trapezium area minus curve in this. We just include this. We did not take separately that area. Area 2, trapezium area minus this curved area. You see here, trapezium area is here. A this plus this. A plus 3 over 2 into A. This is that one, very easy. Curved area, 2 into triangular area. There are 2 triangles, one at this end, other at this end. 2 into triangle area plus 5 trapeziums here. If we count 5 trapeziums here, if you see by exploring that, you will find that. If 5 or not, we will see, but now it's 5, and it's here. I have this diagram here. If it's not 5, we'll check. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 triangles. So we have to take different way. I think. See, let's say it's how we did for. Let us see. This is trapezium area. This here we curved areas. 2 into now 2 times. It is actually 2 times. So triangle area plus 5 trapezium area. That's what we have done. 2 times into this we have done actually. We have done here. One bracket is here. This is 2 triangles, and this is trapezium. How many trapeziums are there? 1, 2, 3, 4, and this is 5th one here, and this is into this is triangle 1 here, 1 here, 1 here, 3, 1 here, 4, and this is 5th one. 5th one into 2. That's fine. B960. Okay, I think again maybe some error caused here. It's here if you see in drawing. This 2 triangles, twice that one. Twice that one. That's okay. So this is twice. We say twice triangle area plus 5 trapezium areas. Twice triangle area plus 5 trapezium areas. 5 trapezium areas, hold on, this sometimes it's very difficult to check everything. Now let us see, we have dimensions there in drawing. You can see half into base into height. This is twice multiply half into base into height. Plus we can say this is continuous. This we are not close this way. This is one dimension. This is coming two already in there. So this is 1.055132. I will speak from there my drawing. This is 0.55132. So 0.55132. Here's a division by 10. Then 132 191. This is 132 191. 132 191. Then it is 191 232. 191 232. 232 256. 232 256. And then 256, 256, 264, 256, 264. Okay, this is fine. And we have already given multiplication of 2 to whole this. So that's fine. Calculation is fine, only writing was the problem. This calculation is exact. Area 3, this is this one. In this what we did actually, we have area 2, we have worked out. So what we did, area 2 here, you can say this area we calculate E960, we took E960, this trapezium area here, this trapezium area deducted from this is this area, 39 point here. So if we deduct this, so we got exact area of 2 not curved, excluding this area. Then we have number 3 here. Number 3 is parts semicircle. So pi RA 150. This is 150 angle here. So 10 degree 150 this one. So 150 or 180. We got this area. Pi to R 150 over 100 is okay. So we have what we say here. Trapezium. Area 2 is good trapezium. Area 2 is okay, fine. Trapezium and this circle area. 2 circle area 1 and other one. So this is trapezium area, one is trapezium plane area, other one is trapezium area. This is D960. This is D960. You can say this is D960, that's trapezium area, area 2, and part circle area is C plus G. C is here 1 and G is here 3. We have this, so we got two rectangle, one trapezium area and one group is circular area, part circular. Now parameter here is very simple, this plus this only in this case, but this is different here. You can say 2 pi r plus 2 pi r internal external both, and 1.5 2 pi r plus 2 pi r internal external both for this one, plus pi r this and pi r this 150 over 80. This this we cannot consider here. 2 pi 1.5 internal one plus 2 pi 2.5 this one here plus pi 1.5 into 150 over 180 plus pi 2.5 30. Actually this one is not full. 2 pi 1.5 internal one, 2 pi 2.5 B96 the external one, but we have to deduct this one, this angle. I think I did not include that. So part circle 1.3, total curved area parameter, and this is important here. So I think what angle it is, let us see what angle it is. This angle here, this angle is, this is not for that, this angle is 150 here, this angle, where this angle has gone, I think I missed something, right? 150 is for this angle, and this angle, which this must go out of this area we have taken, but this angle I think we did not take. That's where sometimes it happens, if you take this angle here, because this must go from this whole circle, and we can say this is here, and we can say here that this is also here. So perpendicular here, you can say end point, or perpendicular we can say, no, this is not end point. You have to cancel this. Sometimes the mathematics is really difficult. Sometimes you have to be very accurate, otherwise you will end 0.90 degree, and then you can say here only. You can say, so let us say dimension angular, linear, and this angular. Just hold on, just working out on this, how it has gone. This is 53. This is 53 angle. So we have to we have to deduct from there 53 angle. This is 53 subtending angle at media. So in this case 2 pi r is okay. 2.5 r minus 53 is 2 pi r, 53 we have to deduct. So okay, we can say minus 53 over 180, 53 over 360. In this r, I can say minus 2 pi r, we have said 2 pi r 53, or we can say percentage wise, we can say in this whole 2 pi r plus 2 pi. In this it is, in this one 2 pi r. If we take this 53 over 360, hold on, we can say like this, okay. Hold on, let us do formula different way, just to learn how it can be done. Let us see, this is one part here, and then there's another deduction. In this we can multiply by 360 minus 53. 360 minus 53 over 360, and now let us see how it comes. Previous answer was 53 has come. Previous was 350. Now it can't be, something wrong somewhere. Well, circular plus semicircular part. Or we can directly take this, 2 pi r. This is circumference into 53, 360 minus 53 into 360 minus 53 over 360. This bracket is over, this bracket is there, the bracket is there. So let us see how much it is. We have typed this in error. Okay, no problem. Let us see what error is. 2 pi r plus 2 pi r into 360 minus 53 over 360. Over 360. Let 360 is not there. We'll fix it. 2 pi r 360 minus 53 over 360. Or we see like this. Okay. Just to keep it separate, it's like this. And now let us see how much it is. 332. So previously it was 360. So it's okay now. It's right. So we caused an error. I didn't deduct this portion. You have to be careful for this. I was not careful. 2 pi r plus 2 pi r into, this is for external one. Internal is okay. Into, maybe there's an angle I didn't note it. And this 360 minus the percentage is 350. If you either take higher percentage. So this is about how much you can say. This percentage how much? Let's see here. Let's just check here. How much is this? This is 360 minus 53, bracket close, over 360. It is about, you can say, what is that taken? Let us see how it is. It is 85.2 of that. So that's okay. 85.2 is okay. I saw fine. This means this much should be. So we have to take 85% of that one. All right. Okay. It's fine. We have done it. Means actually this oversight was error. Now pi 1.5 is okay. That's right. and 150 over 80, that's okay, and other one is also 150, so it's okay, fine. Thank you very much for your patience. I did an error, I caused an error, I corrected that one. Now volume, and that we have to see trapezium area is D, this is D here, and this is trapezium area, and we have to multiply by 10, this is here. How? So this is okay, and this is trapezium area, that's in cell D, that's okay. Then we have to see volume of cubic meter, circular one here, I is total covered area, and says okay, into L, and then 2 into this rectangular parameter 2 into D, and J into L. J is rectangular parameter into L, and then we have to say two end areas of this to I is that area, into, and K into L, so it's okay, K into L. So see, there was an error. I took a lot of time on that, but still error was there, unfortunately. Error was discovered, and it's good that we have discovered it, right? So let's go to now 9. 9 is easy, 9. 1, 2, 3, 4, 5. So you is like childish now. So we can say 9. Let's finish it. Of course, it's already late. It is already one, no problem. Let's do it today. 1, 2, 3, 4, 5, and 1 is 5 into A, 2 is 2.5 into A, and 3 is 4A into A, and then 6 into this, that is 6 into A, 4 is here, and then 5 is 5 into A. So 1, 2, 3, 4, 5, this is C to G, and that's okay. Parameter, let's say 5A, 4.5A, then 4, and then 2.5, 4, and 1, 5, and 8. It's in external, the internal is 4, 1 and 2.5, 3, and this 3 and 2.5, and then 2.5 and 3, so it's okay. 5, 4.5, 4, 2.5, 4, 5, 4.5, 4, 2.5, 4, 1, 5, 8, internal is 2.5, 3, 2. Oh, it's okay, fine. So we can say this area H into J, this is done, and 2 into H plus I into J, that's done. So 9 is done. See how fast we have done. Now is 0. 0 is 1 here again. One circle, semicircle here, one semicircle, 1, 2, 3, 4. It's easy. Let's say 1 is a semicircle, pi 2, pi r, A, and this we are taking 2, so here is also same. Pi rectangular is that, so one a rectangle is this, this is rectangle, this is rectangle here, and we are taking rectangular area 3 because it is 2.5, so 3 is here. We can say 3 into A, and 3A area 3 is same as area 1, and this same as this, so area 2 plus area 4 rectangular area are these, and circular areas these. So rectangular parameter 3, 3, 3, 3, it's okay, fine, rectangular parameter, and these are circumferences, internal, external, both, pi r, pi 2, pi r, pi, okay, it's okay, done. And we can say extrusion now, area G is there, that's rectangular into this, K, and here it is volume, it is here H into K, this is curved H into K, and here is surface area 2 into N, 2 into G plus I into K, I into K, that's is, and also here 2 into H, H is already there, plus J into K, so we have done it. This is done, O is done, 0 is done. Square 0 is very easy, 1, 2, 3, 4, very simple, you can say 1, 5 into this, 2, 6 into this, and 3 is again this. So 1, 2, 3, 4 are these, so simple, and 3 plus 6 plus 3 plus 6, and parameter external, it is 5, 8, 5, 8, internal is this 5, 8, 5, 8, 3, 6, 3, 6, and it is G into I, that is G into I here, and here is, we have taken this state 2 into G plus H into I, 2 into G plus H into I, so it is done. I think it has not taken much time, this. It's already 8:16 now. Okay, good. For your information, I have given you something extraordinary. Though it took time, many errors were committed, but these are not easy work. This work is not easy. It's very difficult work. I think you may appreciate or may not appreciate. That's a different issue. This is complete, very complicated calculations, but very useful one. I have covered, I think, many formulas in this. I'll have not put yet their range names. I'll put them, and if I get more formula, I'll see you soon, and or else it will take some time, and I'll check if there's an error. And the next one, I'll redraw that error. I'll reconnect that error to you, and with this, I can say I have done what I thought to be done. It's already 2 hours and 30 minutes that I hope that you understand what I say is easy, it's difficult, not difficult. You understand what I mean by that, what he said it is, and it's, we understand what is done, what's not done. So we can say that we have done what was expected. I think I've not seen any literature of this type, but I am creating this for us, for you, for everyone. And I could not upload this file, no problem. I'll try to do sometime if I get opportunity, because I don't have any other site except script.com. I hope you got this and you may like it. I cannot say. It's up to you. You may like it, may not like it, but it's very useful as far as it is concerned. And I think now you may understand, you may try yourself. Can you do it yourself? Because you must do jointly, you must draw something specifically for your interest. Not necessary you copy what I said. You can just understand what conception is there. That conception is very important. Once you have that conception, that's fine. There's no harm. You can go to whatever extent you want to go, and that's very important. And I think I've done my job that I should allot it to myself. That job I allotted to myself, in fact. So this is a very interesting phrase. I allotted to myself. No problem. I did it with your blessings and your cooperation. Now I have to close this video, because whatever was done is done. There may be some errors. I apologize for that. I did not check before submission, before submitting to you, but it's work. Very minute work, errors are possible. Even then, I think it's good. Means it's not time pass, but time consuming and time devotion. And I hope you like it. Maybe or maybe not, I cannot say. It's up to you. You people are your own, and I cannot say anything else about that, except that so many formulas are there. You can think of and do it, and then if we meet again, I'll try to find more shapes if possible, difficult shapes, or if you want, you can suggest me something so that we can work out on that, a combination of drawing and worksheet alone and in terms of something. And I hope that I can take your permission in 5-10 seconds. Already it's, I think you can take your permission, and it's going to close now. 2 hours and 35 minutes today with 17 minutes before. And thank you very much.